Are you one of them trying to learn algorithms and trying to master it? But somewhere you feel disconnected and you feel, why on earth am I trying to study this difficult, dry, and boring subject? If that is you, don't worry. I will share you the three principles that I followed that made me fall in love with algorithms. These three principles I didn't get from anywhere, it came unconsciously. But after few years, I'm able to recognize that these three principles are the main reasons why I am passionate about algorithms. Without wasting any time, let's jump into the first principle. But before that, you can apply the same three principles in your journey while developing a passion for algorithms. Let's move on to the first principle. It is called ignite your curiosity. So, how will you ignite your curiosity? Let me start with my own story. I was studying in my college. It was during my second year. I knew a little bit of programming, but data structures and algorithms scares the hell out of me. So I was trying to brush up and improve my C programming skills. So I was watching a lecture by the most famous David J. Malin of Harvard University's CS50 class. He was explaining what an algorithm is, and then he gave an example of an algorithm. He took a thick book like this, that was the phone book, but this is not the phone book, this is the CLRS algorithms book. Nowadays we don't get phone books anywhere, so consider this as a phone book. Now if you want to search my phone number, you have to get my name, Shivakumar. So one thing that you can do, if you are so foolish, you can start from the first page, read every line, every word, and see if there is Shivakumar, and go to the next page, then next page. But this takes more than a day to find my number. I'm not that worth, right? So what will you naturally do? You will just take a page somewhere in the middle, right? And you will see to the left and the right where Shivakumar will be. Shivakumar is in the right. So you will tear up the left side and throw it away. Consider this is a 1,000-page book. It has more than 1,000 pages. You have reduced the problem into 500 pages. Literally, you have half the problem, and now you have only half of the book, so 500 pages. Now you do the same. You take the middle and you see which side Shivkumar exists. It's in the left side, so you tear off the right side and throw it away. David Malin literally tore the phone book and threw it away while he was doing that lecture. It hooked me. What a great way to teach, right? If you are one, a very uh, critical one, so you don't feel the fire of curiosity with this example, I will build upon it for you. This is a 1,000-page book, right? It takes maximum 10 lookup to find the name Shivakumar, if it exists. If it doesn't, it will also take only 10 lookups, and finally you will end up saying Shivakumar is not there. But consider, Instead of 1,000 pages, you have 1 billion pages. Can you imagine the thickness of that book? I just researched a bit. I just looked up ChatGPT to say the truth. The thickness of the book will be 100 kilometers. Can you imagine a book whose thickness, whose first page starts here and ends 100 kilometers apart? If you are from a country where kilometers are not in practice, then it is 62 miles. The thickness of the book is 62 miles, the distance between the first page and the last page, if it has 1 billion pages. Line by line, page by page, if you are going to read, I'm sure, and you must be sure, that you cannot find my name in your lifetime if you did only this thing throughout your life. Do you agree? But let's use the second approach that David Malin showed us. For your information, it is called binary search in program. You go to the middle, that is half a billionth page. You see if Shivakumar is in the left or in the right, and you ignore the first 500 million pages, and you go and do the same process for the remaining 500 million pages. How much time will you take to look up, or how many lookups will you take to find my name, Shivakumar, in that book? You think it will take a bit, right? It will take a while, or it will take few days and multiple lookups, right? No, it's not true. It just takes 30 lookups to find whichever name you are looking for. 30 lookups. Imagine a book that can be held in my hand, which is 1,000 pages. It takes 10 lookups. And a book of 1 billion pages, which is 100 kilometers or 62 miles thick, you just take 30 lookups to find the name. See the power of algorithms. This is why algorithms are extraordinary. Nothing matches. So, what I am telling you from this principle is keep your eyes open for day to day activities that you are doing, or someone else is doing, or some other insect or animal is doing. Try to uncover the algorithm that underlies. If you want another example, when you make a payment in a restaurant or something using currency notes, you will always give the minimum number of notes to satisfy that payment, unless you have some other intentions. So that is called a greedy algorithm. The first one is called divide and conquer, and the example is a binary search. So keep your eyes open, look for algorithm patterns in whatever you see in your surroundings. That will ultimately give you a sense of curiosity in everything that you see. Let's move on to the second principle. I call this principle as experience as many epiphanies as possible. Oh, what is an epiphany? Epiphany means a new realization, a stunning discovery that you hadn't experienced before. I was in my first job, and in the first week of that job, it was training. I was implementing some algorithms and data structures. Initially, I was asked to implement linked list. I was implementing a specific functionality called insert a node or insert an element to the end of the linked list, singly linked list. So I wrote code. I just showed it to my lead. He just looked at it. Oh, okay. Can you reduce the number of lines of code in this function? Okay, let me try. Please give me. I went through it. aggressively and reduced multiple variables and unwanted lines and made it crisp. The initial one had 12 lines and now I have reduced it to 9 lines. I showed it to him. He looked at it. Can you reduce the number of lines again? Oh, no, I cannot reduce the number of lines. I thought through thoroughly. There is no way I can reduce these lines. I was thinking myself. I told him, no, I cannot. I have thought through it thoroughly. I have did my best. I am sure he cannot do that too. But to my surprise, he took a pen and wrote the code. It just was 4 lines of code. In that 4 lines, one line is a conditional statement. And he gave me. What? Is he joking? It's impossible. Then I went through carefully. Oh, he's using recursion, which I am not familiar with. But he was able to complete in 4 lines of code this elegant piece of code. It stunned me. It blew my mind, and I got an epiphany. From that day, I am hooked to recursion and algorithms in general. If you want to become a great public speaker, you cannot just sit and imagine. You have to step onto the stage to do that. In the same way, if you want to develop a passion for algorithms, you cannot just sit and dream about algorithms. You can do that too. I will tell you in the next principle. But for now, you have to write some code. Even if it is a dumb code, you have to write some code. You can interact with programmers who are better than you are and see their code. Is it better than what you are thinking about the solutions? Is it better solutions? Are they more elegant solutions like my lead gave me? You have to watch lectures online from the greats. I have to tell you this. If you are a computer science folk, you are living in heaven right now. Why do I say that? Imagine what types of lectures are available online for free. Robert Sedgwick of Princeton University, his lectures are available online for free, even in YouTube. Professor Charles Lyserson, the book I showed you, CLRS, that L is Lyserson. He is in MIT. His lectures are available online. Stephen Scaina of Stony Brooks University, his lectures are available. And even the greatest of the greats, Donald Knuth, some of his lectures are also available for free on YouTube. What else do you expect as a resource to be available for you to become effective in your field? Can you name one field that has these many grades whose resources, whose lectures are available online for free? No, you cannot, I'm sure. Finally, you can get your hands dirty by making code walkthroughs and small changes and going through high quality open source code bases like Linux. By doing these activities, you will get multiple epiphanies on the way. If something hits you, you haven't experienced something like this before. If something stuns you, if something surprises you will get a realization and you will get an insight. You will not forget that in your life. So go behind the epiphanies. Go behind the things that I told you. Epiphanies will happen for itself. Let's move on to the third principle. I call this principle become the inventor yourself. I was a software engineer in Chennai, India. I was trying to learn this data structure and algorithm stuff so that I can land a better job. So in that process, I was trying to find courses, and I found a course by Robert Sedgwick, the one I told you before. I knew about a library, Arnya Ranna Centenary Library, one of the finest in India. I go to that library. I won't go to the computer science block because it will be crowded. There will be distractions. So I go to the political science. There will be maximum 10 people. Half of them will be sleeping. They will be in their dreams. So it's the best place to learn algorithms. I open my laptop, watch the lectures. While watching the lectures, I don't watch it continuously. I pause it multiple times during the lecture. And then I will close my eyes, try to absorb the material that has been taught. I'll try to visualize the algorithm that the professor painted. And I will try to complete the remaining part of the algorithm in my mind. Then I open my eyes and I will see the remaining part of the lecture. Many times I was able to notice that whatever I conceptualized the remaining part of the algorithm, that was similar multiple times on what the lecturer gave. It definitely boosted my confidence and improved my ability to think in algorithms. Sometimes I do something else. Sometimes while watching the lecture or while thinking, some idea of a new algorithm pops up in your mind, in my mind. That is a slight variation of the current algorithm that I am learning, or data structure also. I will stop the video immediately, close my eyes, go into my flow state, or I will leave my thoughts to flow and I will try to conceptualize that algorithm. I will spend as much time as needed. Once I have something concrete, I will open my eyes and try to search the internet if something like that exists. Sometimes it did exist, there was such algorithms. It was a boost for me. Sometimes there was some research papers of that idea. And many times you won't find anything like that. I will get even more curious and excited. I'll go and spend 2 hours in the internet searching and try to make it formal as an algorithm. While doing that, I will mostly understand that there is a major flaw in my algorithm. Sometimes I will feel this algorithm is stupid. That also is there. But that doesn't matter. The important thing here is the process. When you exercise or meditate or do this half sleep or flow state process of trying to invent an algorithm, you actually get the taste of the real inventor of that algorithm. You'll get that slight drop of that taste, how that inventor of that algorithms felt, that you will feel. Not to the level he felt, but at least a drop of that. When you get this, you will have a realization. This will not only make you passionate about algorithms, but you will definitely fall in love with algorithms. You cannot help not being in love with algorithms after doing this, because you will start to appreciate the kind of thought process that went into designing these algorithms. So I will highly recommend you to reinvent algorithms or invent slight variations of algorithms in your mind if you have that time. If you don't have time, sure, I don't have time for that, then at least spend some time visualizing the algorithms that you are learning or you have learned. That will take a long way in your developing passion for algorithms. So these are the three principles. The first principle is ignite the curiosity. So, what you have to do is look for day to day activities where you unknowingly perform an algorithm that will induce your curiosity. The second one is experience as many epiphanies as possible. For that, what you can do, you can join the tribe of coders, you can watch great lectures from great people, and you can walk through excellent code bases. The third thing is become the inventor yourself. Yes, try visualizing algorithms and try to invent something, even if it is not in the real world. You can do it in your mind, even if it is not a good algorithm that you invent. So today I will ask you to implement at least one of these principles, and I'm sure you will get better in developing a passion for algorithms. You will start liking algorithms even if you apply one of these principles today. As many times as you apply, your interest will go through the roof and you will become a person with a passion for algorithms. Thank you. Hey friend, are you still watching the video? Then I would like to give you a gift. I have created a free guide that breaks down the most common data structure and algorithm patterns. Instead of telling you how an algorithm works, this guide tells you when to use it. Do you find yourself wondering which data structure or algorithm to use in a particular situation? Then this guide is definitely for you. Grab the guide by clicking the link in the description. Until we meet the next time, this is Shivakumar aka Algo Shiva signing off.